All right, this is lesson 4.6, number 29, on page 240. It's about a moving shadow. A man 6 foot tall walks at a rate of 5 feet per second toward a street light that's 16 feet above the ground. At what rate is the length of his shadow changing when he is 10 feet from the base of the light? So you've got a street light, which is 16 feet in the air. So here's my light up here. Let's say that distance there is 16 feet from here to here. This is the light. You've got a man, how tall does it say, 6 foot tall? You've got a 6 foot tall man here. Okay, so the light's shining down out in this direction, and as it shines, his body's going to block out some of that light, which is going to create this shadow down here. Here's his shadow. Right here. Okay. And as he walks, and he's walking toward the light, he's walking that way. So imagine that there's a light up there as I walk. As I get closer, that shadow should get shorter. Okay? When I'm further away, I'm going to block out more of that light and have a longer shadow. As I get closer, that shadow should get shorter. So the change in shadow length should be a negative because the shadow length is getting, the rate of change should be a negative. Now, I do give us some other things that we need to consider here. The man's 6 feet tall. So let's make sure we put that in here. So this distance right from here to here, 6 feet. And the man is walking at 5 feet per second. So let's call this distance here x. And let's call the shadow length s. So x is the distance he is from the base of the street light, and s is the length of his shadow. Now they're telling us that he's walking at 5 feet per second. So x is getting smaller at 5 feet per second. So we can say, again, this is number 29, that dx over dt, or the change in x with respect to time, would be negative 5 feet per second. Again, it's a negative because this distance is getting shorter. His shadow length is going to get shorter also, so ds dt will also end up being a negative. Okay? And we just know that from just experience. As you get closer to the light source, just like when the sun is directly overhead at around noon, you have a real short shadow, where towards sunset, the light's further away, so you're going to have a longer shadow in the evening. So, okay, we want to try to set up some type of an equation that relates all these distances. And what we can do is we can use similar triangles here. We have a small triangle right here. This green triangle would be similar to this big triangle. Similar meaning it would have the same angle measurements but different side lengths. This angle would be congruent to itself. Both of these angles are 90 degrees. So then that would mean that these two angles would also have to be congruent. Right here. So we have all three angles equal. So by side, 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 we know that the sides are proportional then. So we can set up a proportion. We can say 6 over s equals 16 over, what do you think it would be? If you're doing 6 over s, 16 over what would I put? Right, s plus x, correct. So I'm doing the short vertical side over the short horizontal side, divided by the long vertical side over this total long horizontal side. Now it's just a matter of cross multiplying. So 6 times s plus x would be 6s plus 6x. S times 16 would be 16s. And it's always a good idea to simplify as much as you can before you do your derivative. So subtract 6s off both sides. It'll give you 6x equals 10s. Any questions so far? Now I'll just do the derivative with respect to time. So the derivative of 6x with respect to time would be 6 times dx dt equals, the derivative of 10s with respect to time would be 10 ds over dt. And we know that dx over dt is negative 5. So we can plug negative 5 in for dx over dt. And we're trying to find how fast the shadow length is changing, so we're trying to find ds dt. So we have negative 30 equals 10 ds over dt. Divide by 10 on both sides, and you get negative 3 equals ds over dt. And then we need to label it. We're talking about feet and seconds, so the change in s would be change in feet, change in time would be seconds. So what this means is the shadow is getting shorter at 3 feet per second. Any questions about that?